right, we're good on Twitch. Okay, we're good on YouTube. Let's make sure the titles are updated. I got the notification. Awesome. So we should be all set now. All right. I'll wait a couple seconds. But I have both Hello Interview and LeetCode pulled up. I think what we're going to do is flip between the three so that we can practice a whole bunch. And some good refreshers, maybe some new ones even. We got a screaming baby. But, yeah. So let's go to problems here. Head over to the meta screen. Frequency. I don't need that. That's we're already in meta. We've got the to-dos. Easy and medium. Should be good. Okay, so we got a bunch of metas we can do. Looks interesting. But let's go ahead and go through a couple of neat codes. So let's do valid anagram. So given two strings S and T, return true if the two strings are anagrams of each other. Otherwise, return false. An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Okay. I can think of a few ways to do this. First would be to sort the strings. And that would be put them in character arrays. We'll just call it a s.to character array. I'm just doing it this way because I don't have autocomplete, which helps a ton. And then all you gotta do is arrays.sort a with a b. Well, first, actually, what you can do is say if s.length is not equal t.length, then return false, right? Because one of the constraints, the only constraint is that s and t are lowercase English letters. Well, that doesn't account for different lengths, so let's make sure we check that they're the same length. If it's not the same length, then it's not an anagram. So I should probably say what I'm thinking first. Basically, if it's not the same length, it's not an anagram, obviously. However, if we sort them, then all the characters will be in order, and all we gotta do is loop through them, and they will show you what's up, essentially, like if it's equal or not. So sorted by a minus b, wait, not 0, just a minus b. I already have a. Did CD. My apologies if you hear a crying baby. They're right in the other room and we don't have insulation inside of that specific wall, so in hindsight I probably should have. So now that we've sorted both the arrays, all we gotta do is say for int I equals 0, I is less than just c dot length. It doesn't matter which one since they're both the same length at this point. If c of I does not equal d of I, then return false because it's not equal. Otherwise, return true. Run it. It should. Wait, what? No suitable method found. Okay. What if we just do character.compare AB? Still not happy? Does arrays.sort exist? Why do I always... Why are you gaslighting me into saying arrays.sort doesn't exist? It's not applicable. Fine. I won't do it that way. Happy? Well, this is one way to do it. I don't know what it's yelling at me to do, but whatever. It just sucks because I don't have autofill. I want autofill. But another way we can do this, I suppose, would be with a map counting characters. And so if we go through, everything on our string like this, forgot they do have C#. That's nice. If we go through everything on this list, it's not S, it would be T. Then we can say frequencies dot put, and then we can put in C, and the value will be frequencies dot get or default. Maybe you forgot to add import file. That's true. Maybe I did forget to add the import file. It just automatically adds it for me with LeetCode. Ah, crud. That would just be java. Yeah, the util package, java.util. Well, let's see if it fails here too. This is actually much faster. So, I'll leave that blank for now because my brain blanked, but d get or default of C. That's it. 0 plus 1, and then d of 0 minus 1. So basically, we're going to add 1 when C is detected, and we're going to remove 1 when D is detected. And then if at the end the size of frequencies is empty, then we know it's an anagram because it'll have added the same letters and removed the same letters. This should work. Okay, it didn't because it doesn't like me. Default, but it didn't have any issues with a hash map, which means java.util is imported. A header file? I don't think Java has header files. I'm not doing C++. Jar and jam. Interesting. Why no work? We want it to be empty. We get or default it. We go through everything in the list. Oh, they have a recommended time and space of O of n plus m time. Brute force solution, yeah, n log of n and m log of m, which would be arrays.sort, which I showed. That would be brute force for sure. Yeah, rearrange the characters. Does the order of characters matter in both string? Then what matters? Consider maintaining the frequencies. Yeah, exactly. That's what I did. We can do this by having two separate hash tables. Why would we want two separate hash tables? Like, I understand that you can do that, but wouldn't that be slower than this? We want... Oh, because it's not empty. Right. We'll actually say if frequencies.get of D of C equals 0, and frequencies.remove C. If frequencies.get D equals 0, and frequencies.remove D. We'll do that, see if that works. It is an int value. Wait, what do you mean? Not invoke. What? But it does exist. Hold up, what? D doesn't exist. Why do I always fail at the most simple of tasks? Alright, fine. That's freak. We'll do this then. T frequency. Go through all of them. Simply add them. Then we have a second loop. First of all, we can check their sizes. If the s frequency dot size is not equal to t frequency dot size, then we know for a fact that it's not an anagram. They'll have different characters. Let's add I there. So inside this for loop, we're going to want to check every frequency. Basically, we want to compare every frequency. Is there a compare to within a match map? I can't remember. Oh. No. I'm right. Okay. So, yeah, that's not gonna work there. Let's have for int frequency in s frequency. And then, or we can do for character letter in dot I don't remember. Is it keys? Is that what it is? It'll crash if it isn't. All right, we'll put this back in. So s.character at I. S.character at I. Not s. I keep doing that, driving me crazy. All right. Cannot find symbol. What do you mean? What do you mean you can't find the symbol? I tell you guys, I'm going crazier every day. I'm going crazier every day. Okay, it's not dot keys. I get all keys in hash map Java. Key set. That's what it is. Key set. This should run. Cool. So now, at the bottom here, we're just going to say returns true if it succeeds. And so now we're going to say if s frequency dot get letter is not equal to t frequency dot get or default letter, because it might not have it. Say 0 is the default, then we return false, because then the letter does not have the same amount of frequency. Run it. Okay, finally accepted. Let's submit and see if it works. Uh-oh. What in the world? What is this? Wrong answer because it's such an incredibly long string. Your output false. The real output is true. Yeesh. So we add every frequency. I don't. All right, what are we doing wrong? What if I just remove this? I don't see how that would work, but yeah, okay, good. I'm right. I didn't see how it would work. The order could be different. Yeah, so go through every letter. Get the integer at that letter. If it doesn't equal the other frequency letter, and 0 is the default. If it doesn't find letter, then we return false, because then the frequencies aren't the same. Otherwise, if all the checks pass, then yes, it is an anagram and it's true. Yeah, I don't see why this one would give an error. Is there a reason? It doesn't even say why it's the wrong answer. Like, no, it did pass through. It's just returning false for some reason. And I'm not sure why. Oh, come on, Josh. These are the easy questions. These are the easy questions. What's wrong? Put none of these variables are incorrect. It's so much harder to see on LeetCode because of everything else too. It should have accounted for everything. I know I completed this on LeetCode. Oh, there goes a baby. Wow, 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 wow. I don't even know how to search for it. Oh, goodness gracious. Is it on problems that I would search for it? Yes. Anagram. It would be completed. Yes, I did complete it. Let's take a look at what I have and what did I complete it in? Python? Wait, what? I completed it, but it's not showing anything. Show me my code for it. Dude. No. I think this was before I got premium. No. I mean, I know I'm correct. So I'm not sure why it's failing. Anyone got any ideas? Like, am I just missing something here? I can't see myself missing anything. In fact, actually, I think I can simplify this. If we say int array, and we have our frequencies equals a new int array, and we have 26 because it says it only consists of lower English letters, and there's 26 letters in the alphabet. Okay, then we say for I 0, I is less than s. Length I plus, come on, I plus plus, and in here we say frequencies of s dot character at I minus a plus plus, and frequencies of s dot character at, not s, but t dot character at I minus a minus minus. This should actually do what I was looking for originally. And it would be way, way, way simpler. Then we just go through that array. And we say if this item is greater than 0, or we'll do not equal to 0 because it could be a negative number, return false, otherwise return true. This should work. Why? Why is frequencies.length? Oh, because I didn't even structure the for loop properly. Right. Hey, yo! Yes! Alright, finally. Honestly, there's probably a way to simplify this than rather using 2 loops, because this is, I believe, n plus n, which is O of 2n. It'll say O of n, but you could definitely simplify this. Oh, no, it would be more like n plus m, because n would be the number of characters, and then m would be 26, because the number of frequencies. But, yeah, let's see what the analysis says. I bet it will say O of n, yeah. But yeah, it technically is O of n. Yeah. Alright, cool. I was way overthinking that. Dude, doing medium and one hard problem has broken me. I no longer see algorithms the same way. Two-sum. I believe two-sum would be the 2 pointers. So given an array of integers, nums, and an integer target, return the indices I and j such that the numbers of I and the numbers of j equals target, and I does not equal j. You may assume that every position has exactly one pair. Now, here's the question. Here's a question. Is the array in order? Let's find out. 6, 5, 4, 3. Run it. Of course. Return 0. Okay, looks like the array does not need to be in order. Let's fix that. I think this is what it is. The package does not exist? What? Wait, why can I... Is it because this isn't a proper Java version for it? Hold up. A minus B. It's not the proper Java version. There's a screaming baby. Am I able to do this? What? Interesting. All right, whatever. We'll just sort the array. And now we can have int start is equal to 0, int end is equal to the numbers.length minus 1. Start at the beginning and the end. Then we go through. Yeah, I know that's what I'm saying, but I don't think that this is the proper Java version. Arrays.sort, because I tried that, and it'll say that there's no suitable method found. I think this is just the incorrect Java version, maybe. I don't know why that would be, but I don't need it. It'll sort it as is, so that's fine. I just won't be able to have to sort it in descending order. So let's go ahead and int start equals 0, int end equals numbers.length minus 1, and then we continue as long as start is less than the end. So basically what I'm planning on doing here is the left-hand side starts at 0, the right-hand side starts at the end, and if the target is greater, or if the sum of the two numbers of start and end, so here we have sum, and we got numbers start plus numbers end here, okay? If this number is equal to the target, then we know that we have the sum we need. Now I'm going to need a list of integers. Output is equal to a new array list, and we can say output dot hold up, did I confuse myself? Oh, no, I didn't confuse myself. Okay, the output is going to be return the answer with the smallest index first. Oh, okay, so it's just an array of 2. Gotcha, I'm just returning start and end. Okay, I thought I had to return all of them. But return the answer with the smallest index first. Okay, so output of 0 is equal to start, and then output 1 equals end. Then we just return output. Okay, and we can assume that there's at least one that meets the condition, so we'll return null, and it should never hit this. Otherwise, if the sum is greater than the target, so this is what I was talking about, then we know, since it's in order, sum is greater than the target, then that means that we need to reduce the end. Otherwise, if I'm not going to do an else, I'm just going to do an else if, just to make it a little more clear. It doesn't waste that much time. Maybe a couple nanoseconds. And my coding style is like this, unfortunately, for people who always like braces. But let's hit run. Okay. Perfect. Oh. That's right. So the problem with sorting our array... Let's actually remove this and see if the test case is more simple. If the test cases are more simple than I thought. Okay, it's not, because there's negative numbers, of course. What do I use for negative numbers again? Man, that is sad. Let's go in here and see. And which test case is this? This is 7. Use test case. Go back to the question. I wish the test cases would be more thorough. Yeah, brute force would be n to the power of 2 because you would have a nested loop. Given we need to find the indices, can you rearrange the equation and try to fix any index to iterate on? We can iterate through numbers with the index I. Let difference equal target minus nums of I. And check if the difference exists in the hash map. I see. I've never solved a question like this before, so this will be interesting. My current algorithm, time and complexity, right? Time and space complexity. Currently, it is O of n, and I believe O of 1 for space. So O of n for time, O of n for space. But because there's only one loop and there's nothing inside of it that would dictate that it's or O of n in the worst case, because we can return the output here. And then O of 1 because we're not like duplicating this numbers array or anything along those lines. We're just having an integer array of 2 to return. In fact, why am I doing null here? Just do output. I know why I did null, but I can just have output there. So let's see here. So the brute force solution is easy to understand. Let's have our hash map. It's an integer, Why didn't you sort? I did sort before. I have sort here. I just wanted to see if removing that would make a big difference in general. But then I realized that there's negative numbers. And from what I remember, 2 pointers don't work with negative numbers. But then not only that, we need to keep track of the indices. And so when we sort, so there's no, it doesn't say that it's sortable. So that means that if I were to add my test case in here again of 6, 5, 4, 3, it would actually not be correct because we didn't keep track of the indices. It's actually still tracking that we want 4 and 3 at the end of the array, which the target is then 7. But we say 0, 1 because we sort it in order. So that's the reason why that one didn't work. But it's talking about a hash map, and I know what it's referring to. Hash map of integer, which is this one, I believe, being the index, and this one, I believe, being the value of the number. Just call it map. Yeah. Man, honestly, I'm just happy that I was able to like explain the algorithm. It's decently hard to. I'm happy about that. And we'll just cache the amount of items we want in the map since we know what it is. So for int I equals 0, I is less than nums.length, I plus plus. Then we do map.put, and we put the index and then the item at the index. Or, man, let's do nums of I and I. It's one of those two. Is the number always unique? I'm not sure if it is. Yeah, because we could have 2 5s. Right? So that wouldn't be too good of an idea. We'll do that. Wonder if there's a collections.sort for maps. Is there? There is. Let's comment this out for now. Oh, we got a crying baby in the background. I really hope that you guys can't hear the babies screaming bloody murder. It's... Yeah, I really hope that you guys can't hear them. But let's run this. No suitable method. Yeah, that's fine, but let me have a comparator. Ah, there she goes. It's not abstract and doesn't override abstract method compare. Yep, that's correct. So public, is it public int compare? I think it is. Override, compare, and then we have entry of integer left, and entry of integer right. Then we'll just return 0. I just want to make sure this works. Cannot find symbol. Joy. Is it java.util? I'm gonna need to look that up. So, where is entry found Java? This person doesn't have a clue either. I believe what they did though was map.entry. Run it. Hopefully it's happy. It's not abstract and does not override. Goodness gracious. Collections.sort custom comparator. Why does this have to be in the that's what I'm missing? No, it's not. Bruh. No, stop it. I don't want to create a whole new class. No, that doesn't exist either. I don't even think this is Java 1.8. Because it won't even let me do this. I want to do that. That's what I want. What in the world? Collections.sort a hash map. Okay, so I am pretty much right. It was like that. I knew I wasn't that crazy. I just needed to add this integer. No suitable method found. Why? Why are you... Why won't you let me sort? How to sort a hash map. We'll just go even more basic. I suppose I could do that. Do a tree map instead. I think that automatically makes it sort, doesn't it? Set a map. I'm just getting syntax errors at this point. This is driving me crazy. Do I need... No, not collapse, thank you. Not what I wanted either. Import java.util.treemap. Do I need to do that? Huh? I did need to do that. No, I didn't. Illegal start of type. I don't think LeetCode knows what Java is. Alright, we're switching. C#. No, I shouldn't. This is just so frustrating. Got the solution here, and I know the brute force. The brute force is really easy to do. Always has been. Like, all you have to do is go through every item. In fact, I'll do it without it. You just go through every item. go through every item a second time. Then you say if the number of I plus the number of j is equal to the target, you return new integer array of I and j. Otherwise, we're returning null. This will work. Boom. Accepted. Look at that. But it's so slow. It's using a brute force algorithm. And like I said, this is way easier. But there's a solution where... Oh, my mouse battery is running low. Interesting. Okay. There's a solution to where... Yeah, hash map right here. We put every item inside of a hash map. It doesn't even try to sort the hash map, though. Hash map 1 pass. Hash map 2 pass. Oh, I'm actually curious. Let's go to the previous question. I didn't even look at the solution tab. Using a hash table with an array. Yeah, that's exactly what I did. Awesome, I did it right. Yeah, I could have just done a for each loop. Yeah, O of n plus m, I was right. Using a hash map. Oh, there is a dot equals function for it. Wish I'd known that. Yeah, and this is what I tried to do right in the beginning, but it didn't like arrays.sort because I tried to use comparator, because apparently comparator is illegal. But yeah, my last intuitive solution was actually good. Yeah, I was just aiming for the 2 pass. I was not aiming for the 1 pass. Sorting was n log of n, which is definitely better than n squared, but it's not as good as... Hold up. Why can they use comparator? Is this just a different... I'm telling you guys, I'm gonna cry or something. This is crazy. Yeah, because I was aiming for this. In C#, it's not much different. They just use dictionaries. C++, so that's also not all that different. Using an unordered map and everything. All right, let's go with what I was intending on. That is map of integer map is equal to new hash map integer. And we know that it's going to be the length of the numbers, so don't worry about that. For int I 0 is less than nums dot length I plus plus map dot put no I and nums of I. I believe that's what we need. No, they do nums of I, but oh right, Java automatically. Guys, I think I'm going insane. But this is fine. It won't throw errors. You know what will throw errors? Sir Dictionary will. I was thinking of Sir Dictionary this entire time. I'm going crazy. I'm telling you right now, I'm going crazy. Ah, they didn't even add it in there. Alright. Let's go through our second pass. Okay, so what are we doing again? I totally forgot. We're doing the two sum, and we're getting the first and second index that is valid. So how do they handle it down here? Yep, you get the difference between the target and the nums, and if it contains it, then you got your answer. Right. Okay, that's pretty simple. So we got our difference is equal to the nums of I minus the target. I flipped that around hard. Minus nums of I. We don't want a negative number. Otherwise, we could math.absolute it, but probably not. If the map contains the key of the difference and the index at the key does not equal the current index, then we can say, yes, we found our solution, which is the lowest number, I believe, is I, and then the difference, or the index at the difference found. Otherwise, we return null. Okay, this should work. Yes. Perfect. And I understand why it works too, so I'm happy. Please upgrade to Pro for more complexity. I wonder how much it is. Oh, why is everything so expensive? I don't want to deal with that. What's included? Video lessons, written articles, code sandbox, practice problems, code solutions, short quizzes. I'm joining Coinbase as a software engineering intern this summer. Software engineer at Google, Oracle, Amazon. Of course, they do the super popular ones. But... okay, like, this makes sense to me. Let me see if I can explain it. So first, we're putting every single number and its index inside of the map. What this will do is it will overwrite any previous one and put the next index inside of that. This is fine. So now we have the index mapped as well as the number. Then we go through again and get the difference. So the target, so let's say that our target is 8, and let's say target equals 8, and nums of I is equal to 3. Well, that means that we want the difference is going to equal 5, and so we want to see if 5 exists inside of our hash map. Because if it does exist inside of our hash map, then that means that it's inside of the array and it's valid. Okay? And so we check if it contains that key. Then we check if that key is the same as I. So that wouldn't matter for this equation here, but let's say it was 4 instead. The difference is 4. We want to make sure that it's not adding itself. Okay? In order to get that difference. And so that's where that check comes from. Then we return our indexes, which I is going to be less than difference. Then if nothing's found, which something will always be found because that's what our question told us, then it's going to be null. So that's why we do it this way. Let's see, how long have we gone? 54 minutes. Cool. Group anagrams. Now, given an array of strings, strs group all the anagrams together into sublists. You may return the output in any order. Wait, what? An anagram is a string that contains but the... hold up, what? Given an array of strings. Group all anagrams together. Oh. Into sublists. Oh, brother. All right, we need to pick this apart a little bit. Of m times n. Yeah. Okay, let's give it a shot. So, private boolean is anagram. Yeah, first we need to find out if it is an anagram. Let's add another test case where it's act, tac, hat, that, sat. I'm curious what the result would be. Run. Okay, so it is all separate arrays. Interesting. Only care about the frequency of each character in a string. How is this helpful in solving a problem? Correct. Yeah, that's correct. Since the character set is A through C. Yikes. Am I able to return this in any order? You may return the output in any order. Interesting. Okay. Well, let's see how this goes. This is going to be a bit difficult. So, how do I want to handle this? Because the way I handled it here was through the frequencies, and honestly, I could copy this if I wanted. Well, for now, let's jump back into LeetCode and do some problems there. We'll mess with LeetCode is just kind of bothering me right now with how much it is not very friendly with me. Okay, simplify path. Let's see. Oh, that's a long statement. All right, so you are given an absolute path for a Unix style file system, which always begins with a slash. Always, okay? Is that one of the constraints? It's a valid absolute Unix path, okay? Your task is to transform this absolute path into its simplified canonical path. What? The rules of C#, whoops. I prefer C#, but whatever. The rules of a Unix style file system are as follows. A single period represents the current directory. A double period represents the previous or parent directory. Multiple consecutive slashes, such as slash slash and slash slash slash, are treated as a single slash. Any sequence of periods that does not match the above rules should be treated as a valid directory or file name. For example, ... and ... are valid directory or file names. The simplified canonical path should follow these rules. The path must start with a single slash. Directories within the path must be separated by exactly one slash. The path must not end with a slash unless it is the root directory. The path must not have any single or double periods used to denote current or parent directories. Return the simplified canonical path. An interesting problem. String and stack are what are used here. Company's meta has used this 33 times in the past 3 months. Would have liked more examples for this question. These are more examples than I get in any other question, dude. Had a lot of annoying edge cases. Split my... Bruh. Ignore it. Okay, so for example, slash home slash should become slash home because a trailing slash should be removed. Then home slash slash foo should become home slash foo. Then home user documents slash dot dot slash pictures should just simply be pictures. A double period refers to the directory up a level. This should just become slash. Going one level up from the root directory is not possible. This becomes dot 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 slash A, then goes back one, then B, C, then goes back one, D, and then the current directory. So essentially this is ignored. Interesting. The path consists of English letters, digits, period, slash, or underscore. And the length could be up to 3,000 characters. So this is technically doable within O of n squared time if you wanted it to be. Because 3,000 squared is not beyond a 3-second time. Let's see what we can do. This sounds like an interesting problem. It says to use a stack. Yeah, so what we can do is have a string array, split it by basically just a slash. I don't remember if I need this with it, but we're going to split it by the slash. And I'm actually curious, is there a way to ignore empty entries? Split with the limiter. I don't see anything like that, so that's fine. All right, so this should remove all slashes. And then I don't think there's spaces. Yep, no spaces, so we don't need to worry about spaces. All right, let's piece this together. So we've got our path. If it's empty, we're going to ignore it. So let's go ahead and start with that. For string item in split. If item is empty, yes, is empty, then continue. Okay, So now we've taken care of empty items. Let's go ahead and make a string builder output. And all I'm going to do is say output.append item, just so that we can see our current result. We also want to make sure our output appends / at the very beginning. Let's run it, see what happens. Okay, cool. Let's also make sure to append a / at the end. And before doing this, we need to delete character at output.length -1, so that we remove the trailing /. Okay, so that actually worked for 2 of them. That was quick. Great. Okay. I see why it says it wants a stack now. So we do need to count for that. Yeah. And then we're going to say or item dot equals just dot. We're going to ignore it because it's the current directory. There's nothing that we need to worry about there. So now that'll remove the dot there, removes the trailing /. Good. Now we've actually got quite a few issues sorted out. Actually, I think the only thing that we need to worry about now is the double dots. So let's add a stack here of strings. This will be called, we'll call it parents, or parent slashes, or parent directories. And every time something is added here, we're going to say parents.add item. Something like that. Otherwise, we're going to say if item.equals and then ... We're going to continue at the end. But we're also going to say if parents.size, or if parents. Is empty, then just continue because there's nothing there. Right now, all we're doing is continuing. Let's also go ahead and say output.append previous parent / just so that we can visualize it. Sweet. So that does do what it needs to, and it does that. Hold up, I thought we appended / here. Wait, what? Ah. Okay, yeah. So if output.length is greater than 1, then we'll do this. Otherwise, just return the output. That actually succeeds that case, which is great. And we're keeping track of all previous parents, which is good as well. Cool. So I think what we're able to do is output.replace That requires a start and end. Ah, crud. How can we handle this? I'll put delete start to end. We could do index of, but I would want last index of. There we go. And what does this return? Just an int? Yeah, that's good enough. Then we do parents.pop. And this will get us our index. It should be the starting index. So now we can do output.replace the index, and then the index plus we also want the length of the parents pop, so it's equal to parents.pop. Put in parent here, and then put in parent.length here, and we just replace it with a slash. This should work. No, we just have a bunch of slashes. If I do -1, does that remove... Hold up, what? Yeah, I'm aware of that. Let's just make it an empty string. Remove 1 from this. And that should... Oh, sorry, not remove 1, add 1. So we remove 1 up there. Yeah, since we remove 1 here, it'll get rid of the early slash, and then it'll get rid of the extra document at the end. This passed all the cases, but I saw someone say that it's a pain with all the edge cases. So let's see if this succeeds. It does! It passes all the edge cases too. Awesome. That was a fun middle or medium difficulty. I actually enjoyed that one. 4 milliseconds too. I'm happy with that. I bet you it would have been a lot slower with just normal string. But no, that was a fun one. And it's not because I knew it either. It was fun because it was like a real world application instead of just the mumbo jumbo they know. This was a good one. I enjoyed this. Let's see if anyone else. This is my 100th medium problem. Well, congratulations. Is the explanation is poor or am I dumb? Or I am dumb? I didn't think the explanation was poor this time. I just thought it was lengthy, and so some people might not have read through the whole thing because it was lengthy. Because we're humans, we're pretty lazy like that. I mean, I got it immediately. It also depends on your learning style, I suppose, but I also did look at the topics. The topics helped me see that I had to use a stack here. But no, this was great. I like this one. Let's see what the editorial says and if it's any different at all of what I would do. Or what I did. Okay, it handled this the same way. It actually used the stack, which that actually makes sense. Interesting. Yeah, that makes sense as well. In fact, that would probably be a little bit faster. Let's go ahead and try it without that. Our output and see exactly what happens. We pop here, just remove all that. We remove all this. That's pretty much all we need. I could make this less confusing. If the item doesn't equal ... then we can say parents dot add item. But if it does, and the parents is empty, then just continue. Otherwise, pop the parents. Like that. That's a lot shorter, easier to understand. And then all we need to say is string builder output here. And then we go through a loop. No, we would need... Let's also have our leading slash inside of here. And we would need to say string item in parents. And then we would say output.append item.append slash. And then all we need to do is say return output.length is greater than 1. Then it's going to be output dot substring 0 to output dot length -1 dot toString, not to lowercase, toString. Otherwise, it's just going to be output dot toString. Let's see if that works. Doesn't. I broke it. I destroyed it. Mainly because I didn't push. Oh, I did. Didn't it push, not add? Why did I say add? Why didn't it crash? It is add. Interesting. Is there a reason why you're angry at me? Hello? What? I'm fairly certain this is how you do it. Ah. That could work. Instead of there, you append slash here. That would actually make a little more sense. Output.length is greater than 0, then just do output.toString. Otherwise, just do a slash. That would probably run better. What's wrong with you? Why are you angry? Why is there nothing being printed? What? If it's empty or this, continue. Right. If it's not... Oh... Yeah, that might be important. I keep popping when I'm pushing, and I need to continue. Let's run this. There we go. This might be a faster time. No, it's the same amount of time. That's alright, though. No, this was actually an enjoyable question. I liked this one. I wish more were like them, where your thinking didn't have to do with some convoluted algorithm, but instead something that would be the real world. And don't get me wrong, this is an algorithm. This is a data structure that I'm using too. I'm using data structures. It's just, it makes a whole lot more sense. To me, at least. Nice. Cool. Let's see if we can do one more. LRU cache. Interesting. What does this one use? Hash table, linked list, design, and doubly linked list. Oh boy, I don't think I'm very good at those. Meta used this 24 times in the last 3 months. Discussions? Why is this question changed from hard to medium? Well, that's not a good sign. Should be hard any day of the week. You don't get away with bumping it down just because it's a popular question. Since it's easy to think but hard to implement. So, what is this? LRU, least recently used cache. Design a data structure. Joy, I get to be the data structure this time. So implement the LRU cache class, LRU cache int capacity. Initialize the LRU cache with positive size capacity. Int get int key. Least recently used. Alright, this is a bit confusing and convoluted. I'll have to deal with that later. I also want to be able to study up on linked lists and doubly linked lists. So I think I'll wait for this one. Let's go with find peak element. A peak element is an element that is strictly greater than its neighbors. Given a zero indexed integer array numbers greater than its neighbors? 3 is a peak element, and your function should return the index number 2. Binary search. Interesting. Can return either index 1 where the peak element is 2 or index number 5 where the peak element is 6. I don't remember the binary search algorithm. I do know that it's something along the lines of it has to be an array that's in order. And say you're looking for the number 4. Well, you start with 3 and you check, is the number I'm looking for greater than, lesser than, or equal to 3? It's greater than. So that means that you remove all previous numbers, and so now you have 4 and 5. Then you start with 4. Is that equal to, greater than, or lesser than? It's equal to, so now you found your number. It's a interesting algorithm. I'm sure I can implement it, but I haven't done it on my own, so that'll be interesting. But 3 is a peak element, and your function should return the index number 2. The function can return either index 1 where the peak element is 2 or index number 5 where the peak element is 6. That's interesting. Why am I able to return both? At Meta, this happened 29 times in the past 3 months. Yeah, I know, right? Like, if I were to just say 4 into I is equal to 1, I is less than nums.length minus 2, and form a linear solution in this way, and say if the numbers of I minus 1 is less than nums of I, and the numbers of I plus 1 is less than the nums of I, then return that index. I could just simply do that. And then I say return -1 otherwise. Right? This should work. Doesn't, because I know nothing. Yeah, returns index 1. Expected 5 still passes. Well, yeah. It's because it... Whatever. And then if you wanted to, you could say int max and find the maximum one. But there's definitely a way to do this with a binary search. But why is this returning? I tell you guys, I don't know. Interesting. I just want to make sure it's less than I. This one is less than I. This one is less than I. It should return 2. I don't... Oh, whoops, I'm doing -2. I should just be doing -1. There we go. Submit this. Wrong answer! This is for if the length is 3. If it's less than 3, you can just say if nums dot length is equal to 2. And then return the index that's greater. So if nums of 0 is greater than nums of 1, then you return the number, or you return 0, otherwise you return 1. If the numbers dot length is equal to 1, then you just return 0. Or you don't even need that anymore, because then you can just do this, right? If I use this test case and run it now, it's going to be correct. If I submit it, 1, 2, and 3, right, the edge case won't work there, but I don't know. My point still stands. This is a relatively easy question for it to be considered medium. Iterate through the array and compare the element. The ones before and after it. That's not log of n. The global maximum. That would be the local maximum as well. You could also just do math, int number is equal to num, or math dot maximum, or would it be nums dot maximum? I don't know. You could just do this, where I is less than numbers dot length, I plus plus. If numbers of I is greater than the max, stop doing that, please. You're gonna kill me. Then max equals the numbers of I. And then you just return the maximum. Like, I think this would legitimately work. Of course it doesn't. Oh, right, because I have to do nums dot index. Why can't you ever be easy? I is less than nums.length I plus plus if nums of I is equal to maximum. Stop auto-completing max. It's really annoying. Otherwise, return 0 and then run it. And it should find everything perfectly fine. Oh, that's interesting. Fine, we'll do min value. Like, I can play that game too. It's really easy to do that. But what's not so easy is to figure out how to do a binary search algorithm on it. Where you can do O log of n instead of O of n, which would be significantly faster. And like this post says, it's overkill, why bother? But if you want the fastest time, if you want to be able to be the best, you can't think why bother, because this is a great opportunity to learn. To learn how to do the binary search algorithm and other things along those lines. You can test your knowledge. It's not a simple game of did I get 0 milliseconds 100% one-liner. It's not that. Like, and then you can play around with it and hope that you get a higher memory score. Like, that's not going to matter at all. You can, in fact, since this question is so simple, you could probably play around and see what other types of solutions that could be slower than this would be if you wanted to. I find this an actually good question. Should it be medium? Probably not. Should be easy, considering you can just do this, which is really simple. In fact, you could probably make it even simpler than this. I mean, honestly, you can just do math.max here, but I don't. Question doesn't say the array is sorted. Of course it doesn't. It isn't sorted. It doesn't need to say it's sorted. You just look at the examples. The example will show that this is definitely not sorted. It has 1, 2, and then 1, and it's talking about finding the peak element. Of course it's not sorted. You can assume that, actually. Yeah, let's take a look at the editorial really quick. Because I'm sure they have the linear solution. Yeah, linear scan. Yeah, here's an even simpler way to do it. Yeah, that's way simpler than my solution. I didn't even think about that because there is that extra constraint on there that says that nums of I does not equal I plus 1. And so you can use that constraint to your advantage right here. If nums of I is greater than I plus 1, then you know that it's going to be a higher number. And you just need to do it for the first one because it's looking for any index. It's not looking for the top index. It's looking for it's looking for any, which makes it really simple. Algorithm 2, recursive binary search. This would be log base 2 of n. Then iterative binary search, which is log base 2 of n. This one's also pretty simple. Like, all of them are really simple, but you gotta think through it. Yeah, so the middle is the left plus the right. Divide by 2 if it's greater than... Yeah. Simple. The moment I saw this question, I just knew someone will come up with a binary search based solution that I can never come up with during a 45-minute interview. When I saw O log of n, I was thinking maybe binary search, but when I saw the list was not sorted, I was thinking maybe not. Well, I was wrong. Just got this question in an interview. I researched binary search solution, but couldn't prove why this would work. Interesting. How does the binary search algorithm work again? I believe you have the left and the right, just like that, and then you say while left is less than right, just like the 2 pointers. Then you say middle is equal to the left plus the right divided by 2, which gets the center of the 2, the average. Then you say if the number at the middle is equal to the target, right, then we found it and we return it. We return that index, right? And then you say if the numbers in the middle is greater than the numbers, or greater than the target, then we make right equal to the middle minus 1. And I believe if the numbers of the middle are less than the target, then we make the left equal to the middle plus 1. I believe that's how it works, and then you loop through it, it does it again, left plus right. So let's have our example again, 1, 2, 3, 4, 5, 6, and we're looking for, say 2, or let's say 5, we're looking for 5. Well, it's going to drop right in the middle, so left plus right, which is 0 plus 5, which is 5. And that would be this index here. Then we divide it by 2. So 5 divided by 2 as an integer is 2, which would come here to 3. Then we check, is 3 lesser than the target or greater than the target? Or is it equal? Well, the target's 5. So let's say the target is equal to 5, and the target's equal to 5, and so we have the middle equals 3, and so is 3 the target? No. Is it lesser than the target? Yes. So we move the left over to where the middle is and add 1. So that means the result cuts out 1, 2, and 3, because the middle plus 1 starts at 3, plus 1 goes to 4. And so now we start at 4. So it's 4, 5, and 6. And it would be the same the other way. If it were greater than the target, if the target was, say, 1, it would cut out everything from the middle minus 1. So it would cut out and it would leave 1 and 2, right? But that's not our target, and so now we do it again. What's the middle? The middle equals 5. Is that equal to the target? Yes, so we found it. And so it just keeps on looping that until left is less than right, which means that the target was never found, and so we could return something like -1. That's the binary search algorithm. So, okay, I did it without help for the first time ever. I think I did good. But yeah, so that only works if the list is sorted. If the list is 1, 5, 3, 4, 2, 6, this is going to have a hard time finding it. Say the target is 5, right? Target equals 5. So the middle here is equal to 3. All right, so now we're going to cut off everything here, just like before. And so now it's 4, 2, and 6. All right, so now the middle here is 2. All right, so 2 is less than the target also. So we're going to cut off 4 and 2. So that means 6 is left. Well, the middle is now 6, which is not it, and so it's not found. But wait, 5 is inside of this list, but it's to the left of the middle. And so that's why a unsorted list does not work with the binary search algorithm. It needs to be sorted. And so that's why some people, like down here, say, yeah, when I saw log of n, I was thinking maybe binary search, but then I saw the list was not sorted. I was thinking maybe not. But there's a way to use binary search here. And you can see it's very similar to what I typed in. It's just a tiny difference here. So here we'll return the left if it fails. And so we got the middle all situated. We got the left and the right all situated. See how there's the left and the right. Left is less than right. And then we got the middle here. The only thing that's different are the conditions. So we'll say if the numbers at the middle is greater than the numbers at, the numbers at the middle plus 1, then we have the right equal the middle. Otherwise, we have the left equal the middle plus 1. And then we return left at the very end. I believe, yeah, this should work. It shouldn't be a problem. Yeah. So analyze the complexity should be O log of n. And if you know your big O notation, great. Basically, O log of n means this is how many operations and this is how much time? No, this is how many operations, this is how much time it takes to complete. And so the more operations you have, the less time it takes to complete in comparison to O of n, which is linear. O of 1 is just flat line. O of n times log of n is here. O of n squared is here. Then you have things like O of 2 to the power of n, which is way worse, and then O of n factorial, which is the absolute worst. I think you can get worse, which is like n to the power of n. But yeah, like there's a bunch of different ways. Like there's also O of square root of n, right? So there's a bunch of different big O notations that can happen. But so why does this work? Let's break that down real quick. So we have our 1, 2, 3, 1. The middle, we don't know what the target is. We just know that we want our peak, which is 3. So we're going to the middle, and the middle is 2. And so is 2 greater than the one after it, which is 3? No, it's not. So the right equals the middle. Oh, no. No, this condition's not true. So we do the left is equal to the middle plus 1, which cuts off 1 and 2. So now we're left with 3 and 1. So now middle is equal to 3, which we're checking if the middle is greater than the middle plus 1. So is 3 greater than 1? It is. And so the right equals the middle now, which means we're left with 3. And so this returns 3. Okay. Let's see. Do we have a different one? Yes, we do. So this outputs 5. So we got 1, 2, 1, 3, 5, 6, 4. So we're looking here for the number 6, which is the index of 5, right? Or we're looking for the 2, which is the index of 1. Okay, so we start in the middle. So the middle is equal to 3, and 3 is less than 5 because we're checking for the next index. And so we're moving the left over. And so now we're left with 5, 6, and 4. So the middle is equal to 6, and 6 is greater than 4, which means that it will be 5 and 6 left. And then the middle is now equal to 5. And 5 is less than 6, so we move it over to 6, and so now we have our found number. Okay, I see how this works now. It's decently confusing, but that's fine. Let's do this last one here. So 1, 2, and 3. So this becomes, the middle is 2. And then that cuts out 1 and 2. So that leaves us with 3. And so it's fine. Okay, so that's how this problem works. That's understandable. Okay. I think I've done enough talking for the day. I'm getting pretty wore out, and it's a Saturday, so I want to go and enjoy my Saturday. So I think I'm going to end it here. We did quite a few problems today, which is awesome. I think we completed 2 on LeetCode too. It's great. See, 150 total problems solved. We're doing really good. Yeah, we're doing pretty good. I'm happy with how our progress has been. I think I'm going to have tomorrow be the last part for a period of time. I need to rest my brain a little bit so that it can recuperate over all the algorithms I've learned and things along those lines. So what I'm going to try instead is my wife and I have been enjoying the Minecraft manhunts again. And so I think it would be interesting to make a manhunt plugin on Java Minecraft. So I think I'm going to do that. Hopefully you guys would be interested. But yeah, so I'm going to leave it there. Tomorrow will be my last day doing some LeetCode. I'll come back to LeetCode after a period of time. I just need to make sure to rest my mind properly. But yeah, so I will see you guys tomorrow. Take care. Oh yeah, make sure to like and subscribe because that helps me. And feel free to leave comments because I do read my comments. Yeah.